Hello everyone and welcome back. Before we get into today's video, let's solve the previous video's challenge. So as you remember, I mentioned that this sleep function was not well placed. And the reason for that is because on this part of the code, it is working on a static image. So it's working on this train.png image, and after looping over it and finding another sound ray, it's going to go back and look for another one. So it's not actually giving the game window any time to update, because it's not actually working on the game window at this point. It's working on an image that has already been taken. For this reason, I think that the best place to put this sleep function off is right here after calling it. What we want to do today is to detect where a zombie is coming from, so we can effectively place a plant on the corresponding row and defend against it effectively. The global idea is just to create a list in Python to pass the game information into it and read it quickly, instead of trying to loop or match images all the time, which is heavily time consuming. To do this, let's create a game underscore grid variable and set it equal to a list. So this is going to be a list of lists, and we're gonna have basically one list for every row on the game. The game has 5 rows, and we can confirm that because when we look at the game window, it has, well, you can actually see the grid. It's 1, 2, 3, 4, and 5. Basically, every lawnmower represents a row, and we can clearly see that it has 1, 2, 3, 4, 5, 6, 7, 8, 9. So every row has a total of 9 tiles. Let's represent that back in our list. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. What we want to do now is know the coordinates of where each tile starts and where it ends. We have 2 options. We can just check on Paint, every start and end coordinate for every tile. This is known as hard coding. Now, hard coding takes a lot of time and mentally is a lot easier. But we can just create a simple formula and know when each tile starts and which tile ends. This is a little bit more challenging, but in the long term it's a lot easier, because if the grid were to change on a certain update, we will just need to change some values and our coordinates will be back up to date. This is not the case when you're hard coding. You will need to take all the X and Y coordinates again. So the idea is this: we're gonna make a line and basically just measure how many pixels long is this line, and then take a line down here and see how many pixels is this line. This will help us because after that we can just tell the bot to create another line with the same measurement as the previous one we had. So after doing that manually, I got the next information. I'm gonna create a grid underscore increment X variable, and I'm gonna set it equal to 128. And then I'm going to create a grid underscore increment Y variable and set it equal to 173. We are also going to need the information of where the grid's top left coordinates are, and as you remember, it's basically these ones. So I'm just going to set it equal to game area on the 0 index and the game area on the first, on index 1. So this piece of information here should give us everything that we need to know about the game grid. On the long term, we plan to change these zeros, for example, for the name of the plant that we planted there, and maybe we can also change the zero for the word zombie in case we detect that a zombie is coming on that specific tile. But before we do any of that, let's just try and draw the actual grid just to see if we're getting the measurements right. So let's create a function called draw grid. I don't think we need any parameters. And the first thing we need is to get an image where we can draw the grid on. So I just took a screenshot and we're going to be working on this image. So let's open it up right here because we're not going to be using it repeatedly. So let's create a variable called grid_image and set it equal to cv2.imageRead. Then it's in the images folder and the name is grid_sample.png. The next part may be a little bit difficult to understand, but basically we need the row number, which is the index, for example 0, 1, 2, etc. And then we also need the entire information from the row. So this variable here is just going to give us an integer, which is the index 0, 1, 2. And this variable here is going to contain the list itself. To get this information, we need to access the built-in function enumerate, and we're going to set it equal to game grid. Now we're going to access every column number, which again is the index. So on the first one, it's going to be this one, right? So this variable right here is going to give us an integer of the index, for example 0, 1, 2, 3, etc. And then we need the tile itself, which is we're going to set it equal to column. And we're going to access the enumerate function again, but this time we're going to run it on the row. As you may remember, in order to draw a rectangle, we need the top left and the bottom right corners. So to get the start_x information, we're going to run a very simple equation. So we're going to access the grid top left x coordinate, and we're going to add in there the grid increment x multiplied by the column number. So as a simple way to illustrate this, the start x is going to start at the actual grid top left, which is right about here. And then we are going to add the corresponding increment. So if we're on row number 0, what this is going to do is get the grid increment x variable, which in this case is set to 128, and multiply it by the actual index. So on the very first one, since the index is 0, it is going to multiply it by 0 and give us 0. So it's going to start right where it should. And then it's going to multiply it by 1, and it's going to start over here, and so on. To get the y coordinate, we are going to do the same thing, but using the corresponding variables, which is grid top left on the first index, and we're going to get the grid_increment y variable. And then we don't need the column, we need the row. So it's going to do the same thing, but instead of going from side to side, it's going to go down, because as you may remember, the y coordinate represents basically the height. Now that we have where each one of the rectangles is going to start, we need to define where each one of the rectangles is going to end. So to get that, let's create an end_x variable and set it equal to start x, and then just add the grid underscore increment x. And let's do the same thing for the y, for the end y variable. Now that we have all the information that we need, let's run the cv2.rectangle function and input all the parameters that we need. The first one being the source image where we want to draw, and then we need the start coordinates, which is going to be start x and start y. After that, we need another tuple, and we're going to input the end x and y coordinates. The next one is a tuple with the color of the rectangle. Since OpenCV works on VGR, it's going to be probably, if we do 25500, this is actually going to be blue. And finally, we need the thickness of the rectangle. So in this case, let's give it a thickness of 3. After we have run everything that we needed, and well, basically after all of the loops have ended, let's just run cv2.inshow. Let's call the window grid. And the image we want to display is the grid image 1. And let's run wait d so that the window just doesn't simply disappear. So let's save this. Let's go back to the bottom of our code and run the drawGrid function. Yeah, so, well, first things first, the lines are actually blue. So yeah, OpenCV, that's because OpenCV works on VGR format. Now the values aren't quite right. It's too tall and too, I don't know, thin. So we need more width and we need less height. Okay, so what I did now is, instead of just measuring everything again, I just played with numbers and ran the function over and over again until I have this result. So I think this is exactly what we need, and we're gonna keep this information. The final values for the grid increment x is 135 and for the y is 165. Let me hide the code that we don't need at this moment. Yeah, so I guess it's time to look for our zombie, and as you may guess, before we can do that, we need to take an image of the zombie that we are looking for. The image we want to get from our zombies is an image that is within the tile that we are working on. So we don't want to work on the head because, as you can see on this one, well, it's outside the tile. And when a monster dies, well, the head is just, spinning on the air. And this monster was probably on this row right here, and the bot might think that it's on the row up here. So I think that the best option for determining, well, our zombie reference is basically just the body. We are going to be using our sift function. And the question for the next video is, what do you think is better to use in this case, sift or match template, and why? So we're going to be talking about that on the next video. For now, we're just going to take this image and save it as zombie, and it's going to be zombie.png. So let's load that into our code. Let's say zombie underscore image and set it equal to zombie.png. Okay, now that we have our template loaded, let's create a function called zombie detector. I don't think we need any parameters here. And the first thing we want to do when the plot is actually running is take a screenshot and call it train.png. Now we want to take the screenshot only of the game area. And after that, let's create a variable called result and run our sift method function. Now the only parameter that we actually need to input here is the zombie template. because by default, when we are running this shift method function, as you can see here, it is going to open an image called train.png by default. Just make sure that your template is on grayscale. Now, if shift actually finds anything, it is going to return a list. And if it doesn't, well, it might return false or none, apparently. So, if the type of the result variable is a list, then we can safely assume that we found our zombie. The coordinates are going to be, well, let's store the coordinates in a string x variable and a string underscore y variable. Now, if you remember from previous videos, this result variable is going to return the coordinates, but let's consider that the screenshot is only from the game area, so we need to add the corresponding information. So result on 0 index is the x coordinate, and then we need to add the place where the screenshot starts, which is game area on the 0 index as well. And let's do the same for the screen y, but let's change the index for y. Now, as you know, what shift does is that it tries to determine or draw a rectangle over where the query image was found. Now, something is sometimes shift goes crazy and it draws rectangles around like this, and the coordinates may actually be outside of our screen. So if the coordinates are outside the screen, we can safely assume that, well, it found a zombie, but it didn't actually detect the exact coordinates of where it is. Now, if we try to continue our bot with coordinates that are outside our screen, well, obviously the script is going to run an error and it's going to stop. To handle that, let's just create a simple if statement. So the resolution of my screen is 1920. So if basically we detect that either the x or the y coordinates are outside of my screen resolution, then we are going to print a message, which is that the zombie was found, but we were unable to specify the location. And if this ever happens, let's just display what those coordinates were. And those coordinates are going to be, again, the screen x and the screen y. Also, in here, let's just return none. So now let's run an else statement. This is going to run if the coordinates that the bot throws back at us are within our screen resolution. Now in this case, we're just gonna print that the zombie is incoming at, and let's fit the coordinates into it, which again is screen x and screen y. After that, let's just return, in this case, let's return the coordinates screen x and screen y. Okay, so let's go back to our main code, and I'm just going, well, actually, you know what, let's add that part of the code to our main function. So let's see what happens. Let me save, and let's run this. Okay, so I forgot to actually call the main function. Okay then, so let's see how it works so far. Yeah, so far it's gathering sun rays, and so far it is, detecting that a zombie is coming. Yeah. So let's see what happens if we hide all of the zombies. Now this message actually comes from the shift function, and it's saying that not enough matches were found, so no zombie was detected. Now this one came in, and then it is detecting it. So we can say that so far our code is a success. So now let's hide again this drawGrid function, and let's hide this zombie detector function. Yeah. Now the next thing that we want to do is we want to create a function that actually converts the coordinates that we are being thrown back into basically an index of the list. So let's see if we can do that. I'm going to call this function basically just quartz to index, and the parameter that we need is the actual quartz, which can be a tuple or a list. So the x and y coordinates are going to be the quartz. The next part of the code that we need is basically the exact same thing that we have here. So let me just copy it and paste it. So as you remember, what is happening here is that we are basically just we are accessing every possible tile in the game grid. We are getting the x and the y coordinates. So basically what we need is a collision code that tells us if the coordinates of where the zombie is incoming are within a specific tile, and then return the row and column of that tile. Now then, the only thing we need to add here is what basically this does is that it's going to tell us if the x and y coordinates are within the coordinates of a certain tile. Now if it detects that it is, it's going to return the row number and the column number. So we are effectively turning coordinates into row and column indexes. Now let's minimize this, and let's see, I guess we can put this code in our zombie detector. So instead of, if it's found, instead of returning the x and y coordinates, let's return the row and the column. And obviously to get this information, we need to return the coordinates to index function. Now the coordinates are the screen x and the screen y. And in here, let's change when it's printing the information, let's have it print the row and the column. And also on this part, we don't want the screen and the y coordinates anymore. We want the row and we want the column. So let's save this and let's see if it's working. Okay, so we have an error here, and okay, so I know what it is. In our coordinates to index function, we want a tuple, and we are actually giving it 2 parameters. So to fix this, let's just put the coordinates inside a tuple. So I'm going to run it again. So I tested out the bot, but I ran into this problem. And basically, sometimes Ceph detects the zombie just outside the range of where my bot is storing the coordinates for the grid. So for example, in here it's detecting the zombie at 1783. And according to my calculations, the furthest the grid is being detected in my bot is at 1758. 1758 is right about there. So it's detecting the zombie as it's coming in. So the thing about SIFT is that it's basically that powerful. Even if the zombie's image is not complete, it still detects it, but it's giving us some problems. So in order to fix that, well, let me erase this. This is a line I added for a little bit of debugging. What we can do here is store the result of running ports to index into a general variable. We can call it, well, let's say indexes. And then let's say if indexes is none, then we want to return. Else, we can now create our row and column variables and set it equal to indexes. So this should get rid of the problem, and let's see if it works. Let me restart the game. Yeah, okay, so it found a zombie at 2.8 and it's still finding it at 2.8, right? So let's stop the code so far. We are being told that the zombie is being detected at 2.8. And if we look our grid, let's say that it's 2, so it's 0, 1, 2. And then it's being found at index 8. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so we are detecting where our zombies are coming from. And I guess that's it for now. On the next video, we are going to talk about the difference between using match template and using SIFT on these zombies and on the sunlight. So which one do you think is best and why? Thank you, and I'll see you next time.